we're going to integrate the integral from 0 to 3 of dx divided by 5x plus 1. As often happens in math, we layer new ideas on top of old ones. In this case, the old idea is that of u substitution. We have a new place to look for our u, and that is in the denominator now. The reason for that, remember, we're looking at the integral of 1 over x dx can be rewritten as the integral of dx over x. And then the result is the natural log of the absolute value of x plus c. So that's what I mean when I say we have a new place to look for our u. In this case, for dx over 5x plus 1, we're going to let u equal 5x plus 1. du is then 5 dx. So I'm going to multiply and divide by 5 so that in the numerator we have the du. Here I've written it as dx over x. We can really think of it as du over u. So this integral will become 1/5 times the natural log of 5x plus 1, and that's going to be evaluated from 0 to 3. You might say, wait a minute, don't we need absolute values around the 5x plus 1? Because, hey, you keep telling me the answer is the natural log of the absolute value of x. Generally speaking, totally. But if we put either 3 or 0 into the argument of 5x plus 1, right? 3 or 0 in place of x, we aren't going to get a negative number. So I'm not bothering here. So we have 1/5 times the natural log of 16 minus 1/5 times the natural log of 1. But you may recall the natural log of 1 is 0. Therefore, we get 1/5 times the natural log of 16. Now we did that looking through the lens of a u substitution, but we didn't actually perform the u substitution. Let's see what it would look like if we had. We might say here that since du is equal to 5 dx, we're going to write down that dx is equal to du over 5. Totally fine to divide by a constant. Never okay to divide by that variable. If du happened to be 5x dx, you wouldn't divide by 5x because I don't want you to mix u and x. Well, getting back to where we were, we then would have the integral of, now dx is going to be replaced by du over 5. So I'll write that as du over 5 out here. And then we have here 5x plus 1 is u, and so I really have this 1 over u times this du over 5. As far as the limits are concerned, I'd like to point out that originally our limits went from 0 to 3, and those were x limits. In the same step in which we changed the variable, so we changed it to we used a u substitution, in that step we need to write our limits as u limits. In order for us to figure out the limits on u, I'm going to use a familiar structure, that of a table, an xt table in this case. And u is 5x plus 1. When x is 0, 5x plus 1 is equal to 1. When x is 3, 5x plus 1 is equal to 16. I tend to write these numbers here, 3 and 0, in the same order in which they appear in the as limits of the original integral. So then I know where to put them in the new integral. We'll find when we integrate this that we end up with 1/5 times the natural log of u evaluated from 1 to 16. We're going to get the same result, 1/5 times the natural log of 16 minus 0. Next up, we have an indefinite integral. It's the integral of the cosine of x divided by 2 plus the sine of x dx. I'd like for you to pause here and see what you can do with this. See if you can get to the final answer. Recognizing that we have 2 plus sine x in the denominator, and the derivative of that is the cosine of x, we have a du over u situation. Now I wrote down u is 2 plus sine of x and du equals cosine of x dx. And then the integral of du over u is natural log of the absolute value of u plus c. I wrote all that down because that's how a lot of us are going to approach this work. I'd like to see us move to doing some of that work in our heads. And so to recognize that the cosine of x dx is our du, and the denominator here is our u. It's fine to write it off on the side. It's fine to do the u substitution, but mental math is good too. Anyway, the result is natural log of the denominator, so natural log of 2 plus the sine of x plus c. You may be saying, wait a minute, man. Again, the absolute values. And I'm going to say, yeah, but the sine of x is never less than -1. So when I add 2 to that, it'll never be negative. It wouldn't be wrong to put the absolute values. It's just not necessary in this case.